Okay, today I'm going to be talking about the audio filters made for crossovers, for speakers, and audio applications. Okay, what is basically, and I'm going to first talk about the high-pass filter, and then I'll try to mention the low-pass filter, and also I'll demonstrate it on the spectrum analyzer, and try to explain in sort of easy manner to understand. Okay, basically, 18 dB per octave crossover consists out of 1, 2, 3 components, okay? 2 capacitors, 1 inductor. And of course, in our crossovers that we actually make, and this is what a crossover looks like, the one that we actually make, 18 dB per octave, we put the extra resistor, which actually reduces the input from the amplifier or your audio source to a level of the actual tweeter. Of course, here is the input and here is the output. On the output of the crossover, I have got a terminating resistor simulating a speaker, which is about 4 ohm. So, which is this one here on the actual schematics. So, now what is the actually high-pass filter? High-pass filter, if you look at it on the graph here, from 0 to 20 kilohertz scale, in other words, it's not letting any signal through up to a particular point where it actually starts passing all the frequencies up to 20 kilohertz. And that particular point, the crossover point, is actually where the minus 3 dB actually starts of the actual crossover. Now, let's go to the instrument, to a spectrum analyzer. Okay, basically, on the spectrum analyzer, from here to over there, is basically 20, from 0 to 20 kilohertz actually measurement. If you look at it, as I explained, it's basically, okay, the LEDs are flicking, but nonetheless I'll try to, okay. If you look at it like it is on the graph, from 0, it's not passing any audio, any signal, up to particular point, which is this one here, and if you look at it very carefully, okay, if you look at it very carefully, you will see that it's actually on 5 kilohertz. Okay, so that's my minus 3 dB, where the actual high pass starts actually passing all the signal up to 20 kilohertz. So this actual crossover that I'm actually measuring is actually a 5 kilohertz crossover, minus 18 dB. What minus 18 dB means, just to quickly explain, let it stabilize so it doesn't flick. Okay, from minus 3 dB going down, every line represents minus 3 dB. So if you actually calculate or whatever, you will see that somewhere over here, okay, I just have to shift the screen but up on the spectrum, but nonetheless, you can just imagine it, it's actually somewhere over there, and that is actually minus 18 dB. In other words, it's very, very steep. If it's a 12 dB, then it would go like this type of thing. But yeah, basically it's abrupt. And it's very difficult to actually make 18 dB crossover, and they become costly because you do need a specialized knowledge, specialized equipment, and of course high quality inductors, and in order to be able to really achieve 18 dB per octave. Nonetheless, that's basically what the 18 dB per octave does. And as I said, this is what it actually looks like, and of course it's made here by me and designed by me, PC board, lock, stock and barrel. And this is capacitor 1, inductor, capacitor 2, and here is the actual attenuator resistor, which we fit, so it reduces the power going into the actual tweeter. Because tweeter has got a very small coil, and it doesn't require, say, 100 watt to be fed into it in order, to sort of produce enough sound, type of thing. So basically, in a nutshell, that's what it is. A high-pass 18 dB per octave made by Batos at Batos Radio and TV. Thank you.